All right, in this video we're going to carry on with where we were in the last video, trying to figure out the strengths of the different oxidizing agents and reducing agents and use that to build our table of reduction half reactions. But instead of using a spot plate experiment like we did in the last lesson, we're going to be using experimental results. So let me show you some experimental results here, and then we can add to that as we go. All right, here's the two that are in your notes given on 5-3. Excuse me. Now, similar to what we did with the spot plate experiments, one of the most important things for us to know is who is the oxidizing agent and who's the reducing agent, so that I know where to put them in the table. So if I look here and I use my oxidation numbers, gold 3 positive ions here are a +3 oxidation number. This is a peroxide, so remember that's the exception to oxygen. It's a -1 instead of a -2, +1 for the hydrogen. Gold is an element that's a 0, oxygen O2 is an element that's a 0, and this is a +1. So if I use those oxidation numbers, I can see that gold 3 is gaining electrons to become gold solid. Because it's gaining electrons, I know it's being reduced, and because it's reduced, I know that it's the oxidizing agent. So by that definition, this would be the reducing agent. Now, if you want, you could go through and double check that using your oxidation numbers. You see here the oxygen is going from a -1 to a 0, which means it's losing electrons and being oxidized, which makes it the reducing agent. Because this is spontaneous, I remember from my rules that if a reaction is spontaneous, that I know that the oxidizing agent has to be above the reducing agent on my table to be a spontaneous reaction. If it's non-spontaneous, remember that the OA has to be below the RA. So that's what we're looking for here, is basically using that rule to figure out the rest of our table. So I know gold 3 is the OA, which means I know it goes on the left side of my table, and I know it's above hydrogen peroxide, which has to go on the other side. So I can start building my table now. I know that gold 3 positive has to go over here, and I know that hydrogen peroxide has to go below that on the opposite side. And then I can fill out the rest of the reaction. I know from the reaction that the gold 3 is becoming gold solid. So I can put that up here. And I've already done my oxidation numbers, so I know it has to gain 3 electrons to do that. And there's no oxygen or hydrogens to balance, so that one's finished. In the case of the hydrogen peroxide, I know on the other side I'm going to have, actually there is a typo there. That shouldn't be a 4. That should be a 2. I know on the other side, this is going to be becoming oxygen gas. Actually, let me slide that over a little bit. Leave room for my electrons. I know it's going to become oxygen gas, and I know it's also going to become 2H positives. And looking at my oxidation numbers, it went from a -1 to a 0, so it's losing 1 electron per atom, but I have 2 oxygen atoms, which means I'm really losing 2 electrons. So there's the first 2 parts of my table. I've put in the gold 3, and I've put in the hydrogen peroxide, and I've made sure that relationship of this OA is above that RA on the table. So now I can move to the second one. This one, though, is a non-spontaneous reaction. And you might see this a couple different ways depending on the question. Sometimes it's shown like here, where it says no reaction, which tells you that it was non-spontaneous, nothing happened. Sometimes they will complete the reaction and show you the potential products, but they'll just list a non-spontaneous or some abbreviation of that over the reaction arrow to tell you that this was a non-spontaneous reaction. Either way, I can use that information. Now, because it doesn't give me the products here, I can't use oxidation numbers to figure out my oxidizing agent and reducing agent. But I can make an assumption. Again, I would only do this if I don't have any other information. But without any other information, I would assume that this hydrogen peroxide and this hydrogen peroxide are going to behave similarly. So if it was the reducing agent in the first reaction, it's most likely the reducing agent again in the second reaction. So I can label that as a reducing agent. And tin 4 most likely is an oxidizing agent. Again, if you have other data, if they do show you the products, don't make assumptions. Check your oxidation numbers and just make sure that you know for sure, because there are some things that can be both an oxidizing agent and a reducing agent, just depending on the conditions. But we don't have the data, so this is what we go with. Because this is a non-spontaneous reaction, I know that the OA has to be below the RA on the table. So the tin 4 has to go over here. I don't know what it's becoming, so in this case, I actually can't finish the half reaction, but I've at least put them in their order. So I know that the strongest oxidizing agent here is the gold 3 positive, and remember that they get stronger going up the left side. I know that whatever the other tin is going to be my strongest reducing agent. I don't know what that is yet, but I know it will be the strongest. And then hydrogen peroxide, and then gold solid. So then I can give this table a title. So this is my table of reduction half reactions. And there we go. So just like the table that we built from the last lesson, I now have this table, and I could use this to answer any number of other questions. But now I know for sure the relative strengths of the atoms and the elements and the ions that we're dealing with here. Who's the strongest OA, who's the strongest RA. And I can make predictions about other reactions that maybe aren't listed, whether they'll be spontaneous or not. As long as I have my table and as long as I remember this rule, which is kind of key to the whole thing. All right, so give that a shot. You've got some practice questions to try out there. If you have any questions, let me know.